G'day Year 7s, and again, welcome. I've got to change my introduction, don't I? Can I do it the same way every time? And I've got to slow down a little bit. I reckon I'm talking a little bit quickly. So we'll slow things down and speak a bit more clearly, and I will work on that introduction. Anyway, exercise 1G. We have been looking at multiplication, now we are looking at division. So, a few little notes. Division involves finding the number of equal groups into which a particular number can be divided. This can be achieved both with and without a remainder or a leftover. So you might have a remainder when you do this sometimes. So dividing 20 apples amongst 5 people or 10,000 between 3 bank accounts are examples of when division is used. Okay, so if you're going to divide 20 apples between 5 people, you can work out how many apples each person should get. Or $10,000 between 3 bank accounts, you'll work out how much each of those bank accounts should receive. Multiplication and division are reverse operations. Okay, they are reverse, and actually having that understanding is really important when you get to algebra concepts and things like that. So doing reverse, knowing the reverse of operations is really actually quite important to know. Now this is shown, so 7 times 3 equals 21. Okay, so 21 divided by 3 is 7, or 21 divided by 7 is 3. Alright, so all those numbers will be used and they are reverse of each other, if that makes sort of sense. But anyway, you sort of understand, hopefully. Alright, some key ideas. Now, these are some of the notes that you need to take down, so make sure you get all these terms, please, and it may be easier just to, rather than writing all them down, is write that under your subheading. So you should obviously have a heading in your book, exercise 1G, division. Don't necessarily have to write that sort of stuff, but you do need to know these concepts here, and rather than writing all those notes, it may be easier just to write a problem nice and big, space it out so you can write all these little add these notes to it that this diagram has got. Okay, so the number of equal sized groups formed from the division of an operation is called the quotient. So that's basically your answer. Your quotient is the answer part of division. Okay, so the number of equal sized groups you've got is your quotient. The total being divided is the dividend. So the total being divided, alright, so 7 divided by 3. So that's your dividend. Alright, if we look back here at these other examples, so the 10,000 is your dividend, or the 20 is your dividend in these examples as well. Okay, and the size of the equal groups is called the divisor. Alright, so 7 divided by 3, so that's the size of the equal groups, that's your divisor. Okay, same here, 20 apples amongst 5 people, that's your divisor. 23 bank accounts, that's your divisor. Alright, so hopefully that makes sense to you. Any amount remaining after division is called the remainder. Alright, that's obviously the remainder here. Alright, in this particular problem. So 7 divided by 3 gives you 2, and then there's 1 remainder. Alright, now the cumulative law does not hold for division. So remember, the order is important here. You can't have 7 divided by 3 is not the same as 3 divided by 7. Okay, or in this example, 8 divided by 2 is not the same as 2 divided by 8. So you've got to keep the order. Alright, you can't just swap them around like you can with addition and multiplication. The cumulative law applies for multiplication. Addition doesn't apply for division and subtraction. Okay, the associative law does not hold for the division either. So yeah, you can't, like in the multiplication, if you remember, if you have, say, 3 numbers being multiplied, you can do them in any order. Alright, division is very different. Okay, you've got to do them in a particular order, the order that's stated. You can't change the order that you do the division in. Sorry, I'm losing my voice. Hopefully that makes sense to you. Okay, a few more notes. The short division algorithm. So again, the process, a little bit different. It's set up like this, and you've probably seen it before. And how it works involves first dividing into the digit with the highest place value. So you're working from the left side this time and working to your right. Alright, so division's a little bit different. So you start with the highest placed value and then carry any remainder to the next digit and work from left to right. Alright, so for example here, 413 divided by 3. So is it the divisor? This part goes out the front. The dividend part being divided goes in the under this little part here, and you start from left to right. So 4 divided by 3 goes once, and there's 1 left over. So as you can see there, there's a 1 carried there. So now it's 11 divided by 3, which is 3, which takes you to 9. So there's 2 carried over. 23, so 23 divided by 3 is 7, and then there's 2 remaining. Okay, at the very end there. Alright, so hopefully that makes sense, and this sort of shows as you go. So 4 divided by 3, 1 remainder, that 1 gets carried over. Alright, 11 divided by 3, and there's 2 remainder, so the 2 gets carried over, and the last one gives you 7, and there's 2 remainder. So that's basically that 2 remainder is tagged on to the end there. Mental division can be done using different strategies. Again, knowing your multiplication tables off by heart. Very important. 63 divided by 9, I know my multiplication, that's the same as 9 times 7, for example. Alright, so I know 9 times 7 is 63, so if I'm using the 9, 63 divided by 9, it must be 7. Okay, so again, knowing your multiplication is really important. Making a convenient multiple of the divisor, and then adjusting by adding or subtracting, so I sort of looked at that. Below is an application of the distributive law. So 84 divided by 3. So what we're basically doing is breaking this 84 up into something a little bit more manageable. So 60 and 24, for example, and you divide each of those by 3. So 60 divided by 3, which gives you the 20. 24 divided by 3, which gives you the 8, and then you're going to add those two guys together. Or you might have to subtract them, for example. So you might have 90 minus 6 here divided by 3. So you divide the 90 by the 3, subtract the 6 divided by 3, 30 minus the 2. So 90 divided by 3 is 30. 6 divided by 3 is 2, and that gives you 28 that way as well. Alright, so there's a couple of different strategies. And halving both numbers. So with multiplication, you can double one and halve the other, and halve another. Here you can actually divide or halve both numbers if you can. So if both numbers are in the division or even, then you can halve both numbers. So 70 divided by 14 is a little bit more, difficult. I'll try and spit that out. So let's halve the 70 to 35. Let's halve the 14 to 7. 35 divided by 7, much easier, gives us 5. Okay, so there's some strategies. Know your multiplication tables. Using the distributive type law, so breaking a larger number up into 2 more manageable numbers and dividing each of those numbers by whatever number you're asked being divided by, and then halving both numbers. Okay, so not halving and doubling, you're halving both numbers on that one. Alright, lots of information. Make sure, that's the beauty of these videos, you can go back and look at things that you are a bit confused on or can't remember. Alright, use a mental strategy to find the quotient. 84 divided by 7. You know what? I just know my multiplication tables and I know that is 12. Alright, 12 times 7 gives me 84. So straight away my answer there is 12. Okay. Here, 93 divided by 3. I'm going to use this distributive law, break it up a little bit. So I'm going to go, what will I do? Well, it's not hard. 90 divided by 3, and then plus 3 divided by 3. Okay, so I've got the 90 and then I've got the 3. I've got to make sure I add them together. 90 divided by 3, so 3 into the 9 goes 3 times. Make sure I add my 0 back on. Plus 3 divided by 3 is 1, and that gives me 31 as my answer. Okay, pretty easy. 128 divided by 8. I'm just going to use my algorithm for that one. I'm going to use this to solve this problem. So what I'm going to do is the 8 goes out the front. Actually, I need to do that a little bit lower so I can fit that in. Down here. 128 here. 8 into 1 doesn't go. 8 into 12 is my first one. So 12 divided by 8 gives me 1, and there's 4 remaining. And 48 divided by 8 gives me, anyone? 6. So my answer there is 16. Alright, so using that algorithm is actually pretty easy, not difficult to do. Alright, so there's those 3 examples. Oh, actually I shouldn't have done it that way. But anyway, I've done it that way. But you could do it partitioning way again. 128, you might do 80 and 48, for example. Alright, let's actually do that. I'm actually going to get rid of all that. So I'm going to use my distributive law again. I'm going to say 80 divided by 8 plus 48 divided by 8. Okay, so 80 and 48 gives me 128. Divide each one of those. So it just breaks it up, makes it easier. I don't know why I keep doing equal signs like that. 80 divided by 8 is 10. Plus 48 divided by 8 is 6. Gives me 16. Same answer as I got before. Okay, so that's another way of doing it. Alright, but again, you've probably got to know your multiplication a little bit to know how to break it up nice and easily. Alright, using short-term division algorithm. This is what I just did before. So I'm going to rewrite this guy here. 37. 3 divided by 3 gives me 1. 7 divided by 3 gives me 2. And 1 remainder. Oops, if I can spell it. Okay, so 12 with 1 remainder. Alright, here 7, 195. 1 divided by 7 doesn't work, so 19 divided by 7 gives me 2, which is 14. 14 to 19 is 5, so I have to carry the 5 over there. 55 divided by 7, what's the highest I go to, which is 49. So it goes in 7 times, and then there's 6 remainder. Okay, so 27 and 6 remainder. Alright, so hopefully that makes sense to you. That is all. So we've actually took, what, 8 or 9 minutes to go through all the key ideas, but then we could fly through the problems because we went through all our key ideas and key knowledge as I flicked through them really quickly. Alright, so hopefully that makes sense. Again, we're a 12-minute video, so nice and easy. Yeah, hopefully that makes sense to you. You are now ready to rock and roll on exercise, which one are we doing? 1G. If you have any questions, make sure you come and see me. If you need to revisit any of those concepts, you've got the video, you can go backwards and forwards if you need to. I suggest you maybe do a little bit of practice, go over some of these problems yourself in these examples, so you can find some on the internet for a bit extra practice before you come into class so you're ready to go. Alright, hopefully that makes sense to everyone. Come and see me if you're having any problems, and we shall see you in class. Bye bye.